Remember yesterday I said, if you're doing these, all you need to worry about is the angles where the variables are. Meaning, like, if I looked here, all I really care about is like that portion of it. And these two lines are parallel. So, like, if I extended these out and created something like that, these would be your same side interior angles. Well, what was the one property that I said went with the same side interior?
They added to 180.
There you go. That's your whole setup. Then you just solve the linear equation. So the same thing would go on 16. If you're doing 16, again, all I really care about is where the x's are. So if I kind of redraw that, like, all I really care about is this portion right here. Because there's nothing on the other one, so why do I even care about them? They don't affect the problem. Right? Those are my parallel lines. So if I extend these out to try and make it look like a picture from yesterday, this angle and this one are, those are your corresponding angles, and the corresponding angles are congruent, so they're equal to each other. Solve that one out. The same thing would go on 17. Again, like with this, all you really care about is where it's at. So if I was setting 17 up, that's the only portion I care about. The top has nothing on it, so that I don't really care about it. Okay? So again, here's my parallel lines. That's my transversal. What kind of angles are those? Out of the four, which one? Same side, corresponding, alternate interior, what? Same side. So if they're same side interior, they add up to how much?
80. Or 180.
180. Yeah. This line right here, ignore it. Just pretend it's not there.
Doesn't have a
Okay?
label.
Because if I get rid of that, if I get rid of it, that's what I'm left with. Which means, like, since these are parallel, this is my transversal. Okay? Since these are parallel, that means that this angle here and this one are equal. Alright? So this is just a matter of moving things around.
Wait.
What's
Would
that?
it be the other angle?
Which
That
one?
angle?
This one, these two are equal. Well, these two are corresponding angles, so they're the same. But the reason I'm doing this is because I'm trying to get the same variable next to each other to make it a linear pair. So if this is 3y, this is also 3y.
Alright.
So then between them, that's a straight line, so that's 180 degrees. So I can do 4y equals 180. If you divide by 4, that'll get you the 45. And then to get what this value actually was, since x equals 3 times y, now you take the 45, plug it in there, that'll get you the, well, whatever it is, not 115, 135.
Yeah.
You know the ones from yesterday, you can kind of work around anything. Those are the important ones, okay? So, just to remind you, right, the stuff from yesterday was, if you've got a transversal, right, the line going up and down would still be your transversal. And if L and M, the two lines up there, were parallel, all the properties that we pointed out yesterday would apply. So, and again, the difference between yesterday and today is going to be, yesterday I would tell you two lines are parallel, and you would go, okay, the lines are parallel, so all that stuff happened. Whereas today it's going to be, I might mark these things off on the picture. These little arrows will not be there, and it'll say, are these lines parallel? So the difference is going to be, today you're going to be saying things like, yes, the lines are parallel because the alternate exterior angles are congruent. Okay? All right, so for the 7 ways, all right, and I have these kind of in order of the ones that you're going to use the most to the ones that you'll probably use the least. Alternate interior angles are probably going to be the ones that come up the most, or the ones that you'll try and work with the most. So since it's the most common one, I put it first. In the context of this one section, it's kind of split, but as we go through the book, this is the one you're probably running into more. All right, so what this is saying, so I have it written out in words what you need to look for. The thing in parentheses, again, this is like a reason, because you're going to be transitioning into having to write proofs. So remember, your proofs are going to be set up where you have statements in one column, reasons on the other. So that column that has reasons in it, this would connotate, this would be like one of the reasons you might have to put in. So anything that is like a theorem or I point out like that would go on your reasoning sides. And if you can make a list of all the reasons we ever run into, you can use it like a word bank, and it helps. It's not like a miracle thing in writing proofs, but it does help. Okay. All right. So that's the first one. The second one is alternate exteriors being congruent. Again, what I have, like the thing in words, not parentheses, like the regular words up there, that's what you would look for. Right? And if someone said, like if they had a picture and you saw that there were alternate exterior angles and they were congruent, and you said, okay, these two lines are parallel because these angles are congruent. If someone said justify it, your justification would be the thing that's in the parentheses, including the word converse. Okay? What we technically did yesterday was when I did all the properties with alternate interior and alternate exterior, they were written as a conditional. I didn't write every single one out like a conditional. So today it's basically taking the conditionals. If you look in the book, you'll see them. But you have all the conditionals, and if you do the converse, it flip-flops what we did yesterday, which I already said what we're doing. But if you're doing a justification, guys, add the word converse. Do not leave it off. It's a completely different thing. Okay? All right, next one I would say is corresponding. So I have those three in the beginning because, in general, it's easier to figure out that two things are equal. It's easier to look at them and say those two things are equal, as opposed to adding things up and saying they're equal to 180, okay, or supplementary. So usually you kind of like lean more towards things being congruent to each other, and that's what you work with, as opposed to saying the fourth one, which would be that these things are supplementary. So the question will be, like it says up there, can you prove that the two lines that look like they're parallel are actually parallel? And there should be an obvious set that you would look for. Like even if I didn't specify P and Q, if I said name me a pair of parallel lines, these are the only two that make sense to even look at. Because obviously this one's intersecting it, so there's no way it's parallel. So the way you should work with these is you got a list. There's only 4 things on there right now. So you should go to whatever's in the picture, look at the angles they give you. You with these problems, you don't want to try and move things around. They usually have things marked off, and that's all you need to use. You don't have to do anything else. So in this case here, I'm looking at these two angles. So I'll go, all right, I've got this angle here and this one here. Then I would say, okay, these angles here, if I put them together as a pair, I would classify this pair of angles as same side interior. Correct? Yeah? Yeah? Okay. Now we go, all right. So since I know that these are same side interior, I would then go to the list, find out on that list, 1, 2, 3, or 4, which thing involves same side interior, which would have been the last one. And it says, all right, for me to prove that two lines are parallel, what do I have to show that is true about same side interior angles? That they do what? Add up to 180. So you can just do a little check. You go, all right, 130 plus 50 is how much? 180. That means that they're supplementary, so you would say, yes, there's enough information there. All right? Hold on one second. So you'd say, yes, P and Q are parallel. And then for reasoning behind it, because most of these are going to say, give a reason, you can write same side interior converse. Like this would be your explanation, this would be the work, that would be your answer, that would be the explanation too. All right, so let me go to the next one here. So again, all right, so back to like the way you should be thinking, right, is here's my diagram, here's my angles, okay? This pair of angles, could I put a name on it from yesterday? Okay, so on the list, what do I need to be true about alternate exterior angles to say that those lines are parallel? Are they congruent?
I don't know.
Does x equal x?
I guess.
Does something equal itself?
Yes.
They're congruent. Okay? If something equals itself, then you can say, hey, they're congruent. Alright? So this would be yes, still. What about this one?
Yeah.
Wait, like, here are my two angles, correct? What kind of angles are these when they're right across from each other like that? What are they called? What's that angle pair called? It's not from yesterday, it's from before then.
Corresponding.
No. Vertical. Okay? So, on that third one up there, guys, let's stand down. On the third one, there's vertical angles. That list of 4 things that was there, does it mention vertical angles at all?
No.
So, on all of these, there should be things that you eliminate. Like on 7, this line up here, there are no angles marked congruent or given to you on it, so you pretend that thing doesn't even exist. Like, it's gone. Okay? So all that you care about is this line and these two. So your only possibilities for congruent or parallel lines here would be these two. Okay? So you go to the angles that are there. What kind of pair of angles are those? Corresponding, right? So these are corresponding angles. So they're corresponding angles. Are they congruent to each other?
Yes.
Yeah, so corresponding angles, converse can be used, and you should get, was that BE is parallel to CG. Okay? Just a hint, all of them are corresponding angles, converse. It's just a matter of picking the correct line. On 8, this line right here, nothing on it. I don't care about it. This line down here, I don't care about it. Okay? So all you're left with is these two and there. So again, those two angles are corresponding, they're congruent, therefore SP and QT are parallel. And that's it. Alright, this one down here, again, CM, there's nothing on it. I don't care about that. There's nothing on that one. There's no angles on them. I don't care about it. So all I really care about is this line, and this one. So these are the two lines that could be parallel. And they are because these angles here are corresponding. These angles are congruent. So again, corresponding angles converse makes CA and HR parallel. All right, and same way on 10, guys. Like this whole line down here, I don't really even need to concern myself with it, nor that one, or that one. So I'm just left with those two and that one. Okay, these two are corresponding angles, so this would be KR and T. These are 2 theorems you guys can use that I will probably suggest you actually use a number on them. This will give you the 5th and 6th way to put on that list of 7. Okay, the last one's reserved for a few days later. I have these out of order. It's 3-7 and 3-8. I put 3-8 first because you're probably going to use this one more than the other one. Because of what you actually have to apply these. Okay, so for 3-8 to work, you have to know right away that you've got 2 lines that are perpendicular to the same line. The way this thing is drawn, and this is why I say if you just know the first 4, you can kind of get around these. The way this thing is drawn, where they have the right angles marked, they're in corresponding positions. So if you knew a little bit more information, you could use corresponding angles converse to say the lines are parallel. In terms of writing a formal proof, and we'll do it with this tomorrow, for me to use that method, the corresponding angles converse, it requires a much longer explanation than what's up here. So kind of keep this as, I don't know, on your list, maybe write it as this is a shortcut if you know lines are perpendicular. Again, you don't necessarily see it right this second because we're not doing full-on proofs today. But in terms of like writing a proof, knowing this theorem will save you steps in terms of multiple step proof. Okay? But for this one to even come up, like theorem 3.8, you should never write down unless you flat out see that you've got two right angles. Okay? If you got two right angles, then you can use this. If you don't, nothing. You just go on about your business. The other one, you have to have three lines that look like they're parallel. This thing looks like transitive property. It looks like that law of syllogism thing we did. It looks like all of them. Where it's a quick way to link together three lines where separate pairs are parallel to each other. Okay, but the only way this theorem can work, like the only way you should ever bring up theorem 3.7, is if you've got three lines that look like they're parallel. And you also have to know that two sets are parallel, and you have to have like an overlap between them. Like in the if-then that's here, Q is in both of them, so if you just kind of remove that overlap, the thing that you're left with would be your conclusion statement there, that then P is parallel to R. But again, as it goes, theorem 3.7, if you don't got three lines that look like they're parallel, don't use this. Theorem 3.8, if you don't have perpendicular given to you, don't use that. The first four things that we covered are going to be the main things. All right, because even number 7 is limited. Number 7 that we do in a couple days, that's going to be dealing strictly with coordinate planes and stuff. So the first four are the main ones. These are just like shortcuts if you run into very specific situations. Okay, so if you remember these, it saves you time. If you don't remember theorem 3.7 or 3.8, which again you can add those there. If you don't remember them, then you can still do all the problems. It's just going to require a couple more steps. Okay, so make sure, like without a doubt, you take the time to get 1, 2, 3, and 4 down.